Okay, hey guys, so we have been talking about linear functions, okay, pretty much this whole school year. Okay, when we have a linear function, you can write it in y equals mx plus b, okay, where your slope is constant. However, we're going to be talking, and this is linear, if I can spell. And that's why I'm a math teacher, not an English teacher. Okay, so we're going to be talking about exponential functions, okay, and the formula for that is going to be y equals a times b to the x, okay. So exponential functions are defined by an equation of the form y equals a times b to the x, okay. If b is greater than 1, so this number, the function is an exponential growth. And is increasing. Okay? If b is less than 1, the function is an exponential decay. And is decreasing. Okay. And that is just from looking at this formula, okay? Just by looking at b. And an asymptote is a line in which the graph gets close to, but it never crosses through. Okay. So let's look at example 1. It's y equals negative 2x. So to be able to graph it, we're going to make a chart. Okay, so I'm going to do x. I'm going to do my rule, which is y equals 2 to the x. And I'm going to write values. Now, to pick x values every single time, you're going to pick the same x values. Okay, you're going to have 2 negatives, 0, and then 2 positives. So it's always going to be negative 2, negative 1, 0, 1, and 2. Always. Okay. Now, when you do this, to find your y value, you're going to plug in your x values into this equation. So I'm going to have y equals 2 to the negative 2. Okay, and I'm going to get another sheet of paper. Because when you do these problems, you have to remember your rules for your exponents. Okay? So 2 to the negative 2. Remember, we don't like negative exponents. So we're going to have to rewrite it as 1 over 2 to the second. Okay? So 2 to the second is 4, so it's going to be 1 over 4. Okay? And I'm going to convert that to a decimal, which is going to be 0.25. So I'm going to have negative 2 and 0.25. Okay, negative 1, plug 1 in for negative 1 in for x. Again, bring it to the bottom, so I have 1/2. And that's going to be 0.5. So all we're doing right now is just plugging points in. It's 0, y equals 2 to the 0. Okay, anything raised to the 0 power is going to give me 1. So I have 0, 1. So y to the 4th power, which is going to give me 2. And then finally I have 2, I'm going to plug in for x. And that's going to give me 4. Okay. And all we're doing is we're plugging these x values into the equation. Okay, but you always have to remember your rules for exponents, okay? Because it's not guaranteed that you're going to have a calculator on a problem like this. And so now we're just going to graph it the best we can. Okay, this is negative 2.25. 1, 2, and it's going to be right here. This is negative 1.5. It's not going to be perfect, guys. Okay, just do it as best as you can. 0, 1. 1, 2. Then 2, 4. Okay. And then it's going to look like this. So if you look at it and you read it from left to right, what am I doing? Okay, I am growing, so this is going to be a growth. My domain is how far left does the graph go, how far right does it go, looking at my x values. So my domain is going to be all real numbers because it keeps going. Okay, my range is how far up and how far down. So if you look at it, okay, it does not get to 0, okay? So it stops when it gets to this line right here. So it's going to be all right values greater than 0. My y-intercept is going to be where it crosses the right axis, so it's 0, 1. And my asymptote, okay, you can see how it gets very, very close to this right axis of y equals 0, but it doesn't ever cross, okay? And that's going to be my asymptote. It's like an invisible wall, okay? It is not going to go past that wall. So it's going to be y equals 3. I mean, not 3. Y equals 0. Okay, because it's this line. It's not ever going to cross that line. Okay. So let's do number 2 together. We're going to do it the same way. Okay, I'm going to make my chart. Put my rule in. So again, I'm going to choose the same exact x values. 2 negatives and 2 positives. And then I'm going to plug it into this equation. So I have y equals 1/4 to the negative 2 equals. So again, you're going to have to use your rules. And again, I'm going to have to use another sheet of paper. Okay, so if I have this, I'm going to have to distribute this negative 2 in. So I have 1 raised to the negative 2 over 4 raised to the negative 2. Okay. I don't like negatives, so we're going to use my rules, and I'm going to change the location. So I move this to the bottom, this to the top. So I have 4 to the second power over 1 to the positive second power. 4 squared is 16, 1 squared is 1, 16 divided by 1 is just going to give me 16. Okay, so again, you have to keep those rules in the back of your minds. So y is going to be 16, write my coordinate pair. Okay, so 1, I'm going to plug 1 in for x. Again, you're going to do the same process and you will get 4. Okay, plug 0 in. Anything raised to the 0 power is just going to give me 1. Plug positive 1 in. Okay, that's going to give me 1/4. Okay, I'm going to change it to a decimal because it's easier to graph that way. Then we'll plug 2 in. Okay, 1/4 raised to the second power is going to give me 0.0625. Okay, now I'm going to graph these points. So negative 2, 16. Okay, it's going to be right up here. It doesn't have to be perfect because we're just seeing if it grows or not. Then I have negative 1, 4. 0, 1. And I have 1.25. And I have 2.0625, which is going to be really, really close. Okay, so it's going to look something like this. Okay, so this time, if I start from the left of my graph and trace down, I am decreasing, so this is going to be a decay. My domain, how far left does it go, how far right, where it's continuing going forever and ever. So it's all real numbers. Okay. My range, okay, how far up does it go? It keeps going up, but how far down to it goes. Okay. And so it's going to be, if you look, the asymptote is right when you get to 0. So my range is never going to hit 0, so y has to be greater than 0. My y-intercept is 0, 1, and my asymptote is y equals 0. It's not always going to be the same, okay? You just have to be able to look at your graph and be able to point that out. And I want you to do the next two on your own, okay? And when you get done, come back and we will go over the answers. Okay, welcome back. Okay, so let's do y equals 3x minus 1. Okay, to save time, I'm not going to write it out. Okay, but you do need to know how to write it out if you need it, if you don't have a calculator. Okay, pick my x values, which will always be the same. Okay, plug negative 2 in for x. So 3 to the negative 2 minus 1 is going to give me negative 0.8, and it repeats. Okay, plug negative 1 in up here. 3 to the negative 1 minus 1 is going to give me negative 0.6. Repeat. Okay, plug 0 in for x. 3 to the 0 is 1. Minus 1 is going to give me negative. Give me 0. Okay, so 1 minus 1 is 0. Plug 1 in, 3 to the 1 is 3, minus 1 is going to give me 2. Plug 2 in, 3 to the 2, second power minus 1 is going to give me 8. Now I'm going to graph these lines. So I have negative 2.8, negative 1.6, 8, 0, 0, 1, 2, 2, 8. Okay, and then I'm going to draw. So again, I start from the left and I'm chasing up. So this is going to be a growth. My domain is all real numbers. My range, okay, it keeps going up, but how far down does it go? And it looks like this is negative 1. That's where my asymptote is. So it's not going to go below negative 1. It's not going to touch negative 1. So it's going to be y, any value greater than negative 1. My y-intercept is 0, 0. And my asymptote is at y equals negative 1. So let's go to this fourth one. Again, make your table. Your x values will always be the same. And plug them into the equation. So when I plug negative 2 in for x, I'm going to get 13. Plug negative 1 in for x, get 7. Plug 0 in for x, get 5. Plug 1 in, I get 4.3. And plug 2 in, I get 4.1. So now I'm going to graph these. Okay. I'm counting by 2's, okay, for my y-axis to make it easier to graph. So I have negative 2, 13, okay, negative 1, 7, zero, 5, 1, 4.3, 2, 4.1. That's going to be my graph. Okay, this time I am decaying. My domain is all real numbers. My range. Okay, so again, it keeps going up, but it seems like it stops when y equals 4. So y has to be greater than 4. Y-intercept is where it crosses the line, which is 0, 5. My asymptote is at y equals 4, okay, because it does not touch. Okay, so you're going to have problems like this for homework. Okay, so let me know if you have any questions at all. And you might have to change your axis. Like here I had to change my y-axis to count by 3 so I could get it all in. Okay, so do what you need to do. I hope you all have a good day. Please let me know if you have any questions.